So this was back just after the Second World War, and a lot of people that had studied physics or working in the physics area bailed out of that, partially because of objections to building the atomic bomb. And a lot of them got into to biology, thinking that that was a more sane area of research. And neuroscience in particular attracted a lot of the physics refugees at that time. One of the places that these new neuroscientists would hang out, because most of these major universities they worked at were on the East Coast, was at the Woods Hole Oceanographic Institute on Cape Cod. And squid were amongst the things they would come back with. And somebody stumbled upon the fact that there's this giant axon, which is a part of a neuron, in the squid. And suddenly, these scientists who are interested in looking at how the nervous system works realized that they had this wonderful preparation because the nerve was so large, or even this part of the nerve, just the axon part, was so large that they could pick it out of the animal and manipulate it with their hands and do all kinds of interesting experimentation on it. So that's how Hodgkin and Huxley got started, looking at the results from this sort of this squid preparation. You could do recordings from the nervous system by sticking a metal electrode into any sort of an animal, vertebrates or invertebrates, and you can record a multicellular signal. You can record action potentials from multiple neurons, and this had been done for a while before that. You can record electrical potentials from muscles of animals, and that had been done for 50 or 100 years before that. This was the first time that it was possible to understand the ion currents that flowed across the membrane during an action potential.